All right, last part of the chapter, solving logarithmic equations. This, I think, is actually easier than the exponentials because we're not going to necessarily use an exponential to undo a log. We'll just rewrite our log as an exponential. And with that, we're going to end up with nicer numbers in most cases. All right. So let's look at our first example. Log base 4 of 5x minus 1 equals 3. So we're not going to use an exponential necessarily, but let's just use what a logarithm is to rewrite this and solve. So remember that a logarithm is asking 4 to what exponent gives us this piece here, right? 4 to what exponent gives us that? Well, if 4 to the third gives us that, then we just rewrite this as an exponential. So 4 to the third equals 5x minus 1. 4 to the third, that's easy to evaluate, right? 4 times 4 times 4, that comes out to 64. And now we just have a nice linear equation left to solve. Add 1 to both sides. So 65 equals 5x. Divide by 5. And what's that? 13. X comes out to 13. Okay? So all we have to do is take that exponential, use that e that we did back in section 4 to rewrite our log as an exponential, and you should be good to go from there. So next example, log base 7 of 3x minus 2 equals 2. So same thing. 7 to the second equals 3x minus 2. 7 to the second equals 3x minus 2. 7 to the second, I'm just going to write that as 49. Right? So add 2 to both sides. 51 equals 3x. Divide by 3. X is 17. Is that right? Okay. Easier, I think, than the exponential equations for sure. What if we've moved some things around? And here we also have natural log, so we will need to use our calculator again. We need to get everything away from that natural log first. Okay, so add 5 to both sides, divide by 2. So add 5 to both sides and divide by 2. That's going to leave us with a natural log of 4x plus 1 equals 5 over 2. I'm just going to write that as 2.5. Since we have our natural log, the base of that is e, we're going to have to use our calculator anyway and end up with some funky decimal. So here's what I recommend doing with these. We're going to rewrite this, right? E to the 2.5 equals 4x minus 1. I'm going to leave that as e. I'm not going to punch that into my calculator yet. I'm going to save that for later. So we're going to have e to the 2.5 equals 4x minus 1. Sorry, plus 1. 4x plus 1. So our steps would be subtract 1. So e to the 2.5 minus 1 equals 4x. And then we need to divide by 4. So divide by 4. And x is e to the 2.5 minus 1. Divide by 4. This is when I would punch that into your calculator. Because otherwise you're going to use that to do, you're going to go to your calculator like 3 different times throughout this problem. You're going to use that to do e to the 2.5, write down whatever that is. Then you're going to have to do minus 1 and write down whatever that decimal is. And then divide it by 4 and write down whatever that decimal is. So the less that you can, the fewer times that you can go to your calculator and have to copy down a decimal and maybe make a mistake copying down a long decimal, more likely you are to make a mistake. So if you can avoid doing that till the end, you're a little bit better off. So we plug in e to the, and when you do this, I would use parentheses. So put parentheses around that e to the 2.5 minus 1, and then divide by 4. So e to the 2.5 minus 1 divided by 4, and we get 2.796. final example. You won't see too many like this, but I wanted to do one just in case. I don't know, maybe something like this will be on the ACT. Who knows? So here we have log of 2x plus log of x minus 5 equals 2. Now we can't really just take and rewrite this as 10 to the 2 plus a 10 to the 2. We can't undo this log when we have two separate logs. So what we need to do here is condense this back into one log first. So if we condense this into log of, since it's a plus, this would be 2x times x minus 5 equals 2. Now we can undo this. So don't forget, when we have just log, that's the common log, so that's a base of 10. So we would have 10 to the 2 equals 2x times x minus 5. So 10 squared, so 10 to the 2, that's 100 on the left. And then that's equal to 2x times x minus 5. Well, now we're going to have a quadratic, and that goes back to chapter 4, solving those. So we're going to distribute the 2x, so we would have 2x squared minus 10x. That's it for that line. Let's subtract the 100. So we would have 100 equals 2x squared minus 10x minus 100. And then we'll need to factor in order to solve this. We can do that a little bit easier by dividing everything by 2. We wouldn't have a 2 there anymore if I divided everything by 2. So divide everything by 2, and we have x squared minus 5x minus 50. We're looking to see, does that factor? Looks like that would factor into x minus 10, x plus 5. Running out of room on the side there. And what are the zeros from that? We get a x equals 10 and a negative 5. And just like in some of the other recent chapters, we need to check if either of these solutions are extraneous. So if we plug in a 10, does that get us where we need to be? And if we plug in a negative 5, does that get us where we need to be? If we plug in 10, we'd have log of 20 plus log of 5. If we combine that, that'd be a 20 times 5. That's log of 100. Log base 10 of 100 is going to be 2, so that checks out. If we plug in a negative 5, we see a problem right away. 2 times that negative 5 is the negative 10. We cannot do the log of a negative, so that negative 5 is an extraneous solution. And there you have it for solving logarithmic equations.